Hello everyone. In these notes, we're going to discuss some more creative extensions of the interactivity that you find in the previous notes. So first, let's revisit the Tooltec. Remember, it looks something like this, right? When you hover over a point, it's showing the title. Over here, this might be fine, but it's actually not the best implementation, if you think about it, right? If you really want to get the information about a movie, you have to get exactly over the point. And if the points were small, even at the current size actually, it's just really tedious. You have to really want to know what the title of this movie is before you're going to get any information. Right? A better thing to do would be just recognize when the mouse has gotten close and then automatically decide to show the title when the mouse has gotten close enough. Right, so how can we implement something like this? The main idea is to do something called a Voronoi mouse over. So what I'm showing here, each of these little grid cells, right, is basically as I move my mouse, when you go from one cell to the next, the closest point to that mouse location is given by whatever is kind of in this box, right? So in this box, the closest point is this orange one. In this box, the closest point is this pink one. And then the boxes get really small when the points are really clustered together. It's called a Voronoi tessellation. In practice, you wouldn't actually be showing this background Voronoi tessellation. It would be kind of in the background, but then you would just register when the user's mouse has moved from one location to the next. And when they move from one location to the next, then you just do the update, you change the tooltip and the size of the points, just recognizing that they've moved from one cell to the next. Okay. So how do we actually implement anything like this? We're going to use the D3 Delani library. So Delani is just a word for this kind of tessellation scheme. So when I define this Delani object, what does this do? This first argument is the array defining all the movies. And I'm getting here is what I want the x coordinates in pixels to be. Here is what I want the y coordinates in pixels to be. And then based on each element in this array and the mapping to pixel space, it's basically calculating this sort of tessellation in the background. Right? Once I have that defined, now I can use this Delani.find function. And what it's going to do is I can pass it in the x and y coordinates of where the mouse is, and then it's going to find me the index in that original array of the closest sample. Right, so in this case, the mouse is located at this coordinate, and it's returning the movie index that is the closest to the mouse. This is just a different syntax. So far, I know I've been using the D3.pointer. This is another syntax. We're doing the exact same thing. I could have also used D3.pointer here, but that's an aside. Once I have that index, I'm just moving the location to, this is getting the index of that movie. And so data at ix is getting that current movie, and I'm moving the tooltip to the pixel coordinate for that movie. And then I'm just getting the name of that movie from here, data at ix title. Okay, so that is the main idea for the Delani thing. Notice that I'm not actually registering a mouse over on the individual points. Instead, I'm recognizing any time the mouse has moved on the overall SVG background, right? I didn't actually have to hover over the point in order to get that change. Right. Okay, so that is one way that you can make much smoother interactivity compared to actually having to hover over every single point. It applies to more than just scatter plots too. You could imagine if you had a whole bunch of time series lines, you might not want to hover exactly over the line in order to show information about it. You might want to just say, I'm close enough to the line. The same principle applies. You can just do a Voronoi tessellation around the entire time series, and then you can see which is my closest time series. Okay, enough about the Voronoi. Another kind of very useful extension is to do graphical queries. So we already saw graphical queries in Shiny, we can do the same idea in D3. So remember, the idea is make it so that your selection is itself a visualization. In that way, your selection inputs aren't just some kind of extra text or UI graphical thing, it's actually encoding information. It's really cool when your selections are increasing the information density of your visualization. So here is the same kind of example as our legend example before, except the size of the bars represents how many movies belong to that group. And so when I click on the action bar, it's selecting or deselecting all the action movies. When I click on drama, it's selecting or deselecting the drama, and I can select or deselect multiple of these at once. Right. Just like the legend example, except the bars, these rectangles, encode the number of movies. Right. So how do you do that? Okay. One important point, compared to Shiny and R-based visualizations, it's really kind of tedious to do any sort of data manipulation in JavaScript. There are some libraries that are making it easier, but as far as I know, right now, it's still kind of tedious. So usually whenever I want to make these kind of graphical linked visualizations, I will compute all the data sets that I will need in advance. I'll save those into some CSV and then read any of those files all at once at the end. So what I've done to create this visualization, I actually created a separate data set that's just calculating the number of each of these types of movies, and I've saved that into a separate CSV file. Right, so that's in this stats.csv file. This is the syntax you can use to read in multiple data sets at once into a D3 visualization. So it's going to pass in to visualize both the movies array and the stats array. Okay. Once I have this stats array, I'm doing the usual kind of D3 bind. I'm binding every single count for each genre, and I've appended a rectangle. Once I have those rectangles, I can define the locations and the size of the rectangles. So for the locations, I'm using the same code that I use for the ordinary legend. But now, instead of setting the width to be some fixed, just like a standard square, I'm saying that the width should encode the number of movies which I've given in the column called n in this CSV file. It's the total number of movies for that genre. X2 is a new scale that I defined that maps the number of movies in that genre to the number of pixel width that rectangle should have. Okay, once I've done that additional rectangle encoding, everything is the same in terms of my interactivity. I'm using the same toggle function that I used for the plain legend. But now the user is able to see when I toggle which group, which one's going to change more movies or not. So there is two different kinds of interactivity. They're not strictly necessary for a lot of cases, but then if you really want to take the visualization to another level, it's helpful to be thinking about these sort of subtleties. It just makes the amount of information that you can display and the smoothness of the interactivity much better.